So yeah, last half hour is was supposed to be dedicated to just like show and tell. Like if anyone has anything random. And we didn't want to plan this for a reason because people sometimes show up with stuff last minute, and we had like really cool things. The first FOSDEM or the second, we had I don't know, like Paul showed up with his like Spectrum Wars thing, stuff like that. So I'm hoping like we will get more of that. So yeah, I don't have any slides or anything. I don't want to like take over this. Like if someone has something they want to show and could be like short, random, we can do a sort of lightning talk style thing. I just quickly want to. Just remind people that I work for Edis Research, even though I don't wear the gear as usual. Like we build the usurps, they look something like this. This is like the smallest one that we have. You can also get it in a case. So this is just a very nice and easy way to get involved in usurps. I don't know the exact price point off by heart, but it's more expensive than like a Pluto, for example, or even a HackRF. But it's still a very very useful. But it's USB 3, and then it has there's a reason like it's. Yes, there is. Yeah. Like this is actually a prototype, but it works fine, and this is a more elaborate version of the same thing. It has 2 channels. You can do 2x2 MIMO with this. So I haven't one of the things I talked about earlier is like, can I use this for the GR radar without any modifications? And I haven't tried it yet. I assume that there will be more leakage than there will be with other setups. Have you tried it?
Yeah.
Oh, okay.
We still use GR radar for like if we show the institute to new students like first.
But not with this, right? Use N210s for that.
No, depends. I set up both.
Okay, fair enough. Yeah. Like we have a whole bunch of things that I didn't want to carry all the way from California. But if you have any questions about them, like I'm going to be here, just ask me. All right. I know you wanted to show something. You wanted to show something. Anyone else? You wanted to show something?
I don't want to show something, but I have a challenge for everybody in the room with an SDR device.
Okay. You have a challenge? Maybe we should like get you on early then. Anyone else? Like I want to know like how many people are actually interested in showing something. Okay, you first. Then, sorry, what's your name?
Gerd.
Sorry?
Gerd.
Gerd and Paul. And Paul, yeah. So, and you are Hans?
Yeah, Hans, indeed. I can talk loud enough, but I'll... Okay, so, does this work? Okay, so it's an easy challenge. We're from the ham radio info booth over there. We put a signal in the air around 50 megahertz, and it's your job to find it and see what it says. 50 megahertz, something above, a little bit above 50 megahertz. And I challenge you to be the first one to see what it says. And then, of course, you can connect your computer to the beamer if you want and show it. But yeah, let's go.
Okay. Gerd, do you wanna connect your stuff?
You first.
All right.
I'm downloading the.
Oh, you're downloading. Okay.
So is this still being recorded? I hope not.
So no, it is actually.
Oh, yeah. Sure. Yeah.
We need a VGA. We have the HDMI thing. It wasn't
Most
adaptive.
of the recording is semi-automated.
I have a. Do you have HDMI?
Yes, we do. But it mostly works.
It mostly works. Mostly is good enough.
Some of the time. But do you what's your native? Your native is let's go. Let's do this.
Oh, it says native. Yeah, it's fine. We'll plug this in.
How many megahertz? 50?
50.
So actually, we're going to VGA.
Exactly 50?
No. Above 50.
50 something. It has to be CW. They're grumpy old hands. I can say that.
That's what you get, of course. It's.
There's no guarantee that external adapters work. That's the sad truth of this whole setup.
It saw a new display, but the display is not seeing it.
Yeah, okay.
So
That's the usual problem that we had today a couple of times. I guess there's really nothing that I can actually do about that, to be honest.
I mean, you can go straight into the.
Yeah, we can go straight. I mean, this is not going to be only on the video then, not on the slide.
Yeah, well, it's only a teaser, so that's fine. I think it
Better
should
than
not.
nothing now.
It is. I mean, the box. The laptop sees the box, but the projector does not see the box for some reason.
I guess there's some. It's probably just picky, and we never got the time to like figure out which.
Okay, given that we only have 20 minutes left, I'll go real quick. My name.
Can you say under 5?
Oh yeah, oh sure. I'll go really quick. Okay. 5. So I'm one of the people who missed the deadline. I tried to submit something, but then I heard, no, it's already closed. So look at this as possibly a teaser for next year if the PC will allow it. We do radio astronomy as well. We're a group of volunteers. This is our dish, 25 meter in diameter. You can do some real interesting stuff with that. So I'll skip all of this. This is people working on it. I have 5 minutes. You can see it move. This is the very first time we got it to move again because it's been decommissioned. This is the receiver setup, sort of, with LOs and antenna plugs, rubidium, and over there you see an SDR home-built backend with all kinds of different modes. It samples at 70 megasamples per second, 10 bits ADC. It does windowing, it does real-time FFT, because this thing is by now almost 10 years old, and there's no way a PC could keep up with it. Internally, there's a Spartan 3 FPGA. This is a very simple flowchart that does integrate complex magnitude, FFT complex magnitude, integrate, and then spit out the spectra as Ethernet packets with all kinds of different modes for more or less resolution, for pulsars, or all that kind of thing. This is what we do what we see when we scan across the galactic plane, and all these. So you see the hydrogen line, and all these curved structures actually correspond to the spiral arms of the galaxy. This is M31, the Andromeda Galaxy. This is when we look at pulsars. This is multiple recordings of each about 20 megahertz wide. And this is when you time a pulsar for a year. This is the planned and the measured periodicity of this particular pulsar. And this is looking at pulsar live without de-dispersion, without folding. The slanted pulses that you see, you can actually listen to live. And we also do some support for education where students can actually come and do these recordings and process the data. And I hope that's under 5 minutes. Thank you.
Before you unplug the mic, maybe you went over typically, but where are you based?
Okay, yeah, we're based in the Netherlands, Dwingelo. It's an old radio telescope. At one time, it was the largest steerable radio telescope in the world for about a year and a half. In 1956, it was opened, and it's been decommissioned somewhere in the 90s. And it's now being run by volunteers, and I'm one of them. It's a whole group of volunteers that are behind the effort to make this thing work again. And I happened to build an SDR because we needed one, and we couldn't get one.
Are you in touch with like other like groups like yourself, like
Yes.
Kissera?
Yeah.
And,
Yeah.
Okay.
So for those who are into radio astronomy, in September there will be a new European conference on amateur radio astronomy in Stockholm in Germany. Definitely worth visiting if you can.
Is Marcus Leach coming to that conference?
I don't know. I honestly don't know. This is organized.
I would go to that.
Okay.
Okay. Thank you again, Paul.
Okay. Thank you.
HDMI. Okay. Nice.
can just give a small update. He won.
Okay. Can I have on the HDMI cable, please? I don't know if I have the just on HDMI
Yeah, that should be
cable.
Here it is.
This one. Okay.
And we'll plug this end into this one, which is super awesome from a usability point of view.
Sorry.
No, it's not your fault.
Sorry, what's your name? Like the winner? Simon, do you wanna show us something off? Like,
Well, definitely, it's not the most stable program.
it doesn't matter. I mean, if you have,
It's pretty much priced now.
okay, you can get some nerd credits that way.
And switch on.
So while you're, well, I don't
No.
know.
Up. Okay. I'm.
Do you want to just
just switch the.
I don't know how to do that.
Okay. I can show you some pictures on my directly. I think my laptop. What? HDMI. This one. I'm Gail Muscat. So I'm hacker in residence in the French Air Force. I'm civilian, but they are hosting me on a French air base. But I'm also hacker in residence in Quant. Quant is the European search engine, and I'm working on security and privacy for Quant and for the Air Force. So I will show you all the picture of on my computer. What you are seeing here is all my work on the Tesla car. So Tesla is one of my favorite hobby, and the boss of Quant, when he see what I'm doing with the cars, he decided to hire me and to see what I can do on the privacy of cars. So I just come with this kind of devices. So this first one is to exciting tires. So the IDs of the radio IDs of your tires can be a way to identify that it's your car, it's you are here. So this device is really useful because it helped me to excite the tire pressure measurement sensors and to be sure that it is emitting the data. So this is the GQRX frame on 433 megahertz. This device is the plug of the car. So you have in the Tesla network this kind of plug. You have a push button here, and when you push this button and the plug is on the AC power, you can automatically open the trap of the plug, the charge port of the car. So Tesla used the same code for all the cars and all the supercharger. It's not so dangerous, but it's really funny to show and to help people to understand what is radio frequency, software-defined radio, because this radio frame is really simple, and it's a good way to help people to have. So I use this software, Universal Radio Hacker, in order to help me to understand this signal. I have teachers and university to train children to software radio, to radio. So this is my daughter, just back of the Tesla, listen to a PixSat with an Aero antenna. And for me, it's a way to have my children, my daughter and my son, to be familiar to this kind of subject. So it is just a way for me also to make ham radio sexy. So if you are doing ham radio in a Tesla, it became very, very sexy than just talking in talkie-walkie. And I use this kind of radio and APRS network. APRS is a tactical network of ham radio on 144.800. So you can send telemetry, you can send data, you can send the temperature of the battery, the tension, the voltage of the battery. So I use this kind of radio and antennas around the car in order to send his position, but also my blood pressure, my heart rate, and I use the Aero antenna to send this telemetry, to the ISS, and to use, why not, the SatNox network in order to have my heart rate telemetry at 500 kilometers. So it's funny, why are we doing this? Because it's funny, but it's also a way to explain to car manufacturer, to search engine, to everybody who is working in the web field that radio can be fun, but it can be also dangerous, and it can make dangerous things for the security, but also privacy. And I will just finish to talking about ILIA. ILIA is the official program of the French Air Force. It's an innovative program to deploy ADSB, AIS, and maybe SatNox station in order to observe with a secondary way than just simple radar all the plane, all the boat, and I hope all satellites above us. That's all. Question?
Do you say you were the hacker in residence? And then
Yes.
Is that actually a thing?
It's my official job on my contract. Hacker in residence. It's and at Quant, but also on the French Air Base, we have 7 developers, hackers, officially hosted by the French Air Force, each in a field. So me, I'm dedicated to radio and embedded systems.
Cool.
So you have a Tesla and you do ham radio and SDR. How much RFI do you get out of a Tesla? How much does it pollute the spectrum?
Oh, you know, I use a lot of antennas around this car. So I use, for example, a 10 meters mast, for example, to have a V inverted antenna. So if I'm just driving, I'm just focused on APRS network and ADSB networks. But inside of the car, I don't measure a lot of data because of Faraday, like a Faraday cage. So the Tesla produce a lot of data, a lot of radio frequencies. So it's in Europe for the ISM 433 for the keys, the key fob, the tires, and the.
But I mean the drive system. How much RFI does it make? How much unwanted emission?
I don't know. I don't know because I don't have the big cage. I'm building now a vehicle research lab in northern France, and we will have in this lab all these kind of instruments that can help us to understand what a car is emitting, not only a Tesla. I can do this also with a Peugeot, but it is more simple. It's more sexy to talk about that with a Tesla. I can answer. I hope to answer to this question next year in a talk.
At FOSDEM?
Yes.
Okay.
I will subscribe on time because I was late, so I will subscribe on time to explain that.
Cool. Thank you again.